Hey, what's up, people? This video will be aimed at anyone with little or no programming experience whatsoever. So, unless you're already familiar with general code syntax such as data types, implementation of comments, variables, functions, conditionals, loops, and all that, you should benefit from watching this video all the way through. By the end, you should have a better understanding of the building blocks for the scripts that we will be working on in upcoming tutorials. And even better, this material should be useful for you if you ever have to interact with other programming environments. Now, if you find that the material covered in this video is not immediately clear or easy to grasp, that's okay. There's no reason to lose motivation. I promise that once you start seeing these concepts in action, you'll be able to internalize them and feel more comfortable implementing them. So with that being said, let's get started because there's a lot to talk about. So before we start, let's go ahead and open our text editor, and we'll open a new file and save this in our desktop as coding 101.sco. And the first thing that I want to talk to you about is comment syntax. So roughly speaking, a comment is a piece of text or code that has no impact whatsoever in the execution of the program. So it's essentially invisible to RTcmix. Comments are only meant for making observations or hints, clarifications, or reminders about the code, either for yourself or for other people interacting with the code. In RTcmix, as in other programming languages, we have two different ways in which we can write comments. So the first one is using two forward slashes, which allows you to comment on a single line. So we can type, "This is a single line comment," and you can see that Visual Studio recognizes this as a comment because it's color coding it with a dark gray, which is barely visible. And the second way that we can write comments is using a pair of slash star, which this autocomplete. So it's a pair of slash star and star slash. And so any text that we type inside or in between these two things will be considered as a comment, and this allows us to write multiple lines of comments without having to type double slashes every time we want to write a new line. So for example, we can type, "This is a multi-line comment," and still color code it. But if I type something outside, so let's see, ceci pas un commentaire, this would not be considered a comment based on this syntax. So that's pretty much all you need to know about comments. We can now move on to variables. So a variable, as you might imagine, is a value that can change during the execution of the code. And this value is stored or referenced by a label or identifier that we can name however we want. So for instance, we could declare a variable named blue and assign an arbitrary value to it, let's say 255. And so in this case, we would say that the variable's identifier or name is the word blue, and its current value is 255. So using variables can actually be extremely useful and practical because you can reference the same value anywhere in your code by simply typing the variable name as opposed to the actual value. So for instance, we could write an arbitrary mathematical expression such as this. So we can say x, which is another arbitrarily named variable equals to blue times blue divided by 2. And so if we were to change the 255 to a different number, every instance of the variable blue would change accordingly. Now, one common mistake as you start using variables is forgetting to declare the variable before you use them, or forgetting to declare it at all. So if we were to invert these two lines, for example, the computer wouldn't be able to evaluate this line of code because the variable is declared afterwards. And we can actually verify this if we go to terminal and run this script on RTcmix. So we're going to type cd to go to our desktop. Remember cd stands for change directory. So we're gonna go to the desktop, assuming this is where you saved your coding101.seo. Remember to save this, by the way. And we're going to hit return. And now we're going to type cmix left arrow and then coding101.seo. So when I press return, you can see that RTcmix is complaining because the blue variable is apparently has apparently not been declared yet, and it's actually here, but because the computer starts from top to bottom, it doesn't know what the value inside the variable blue is. So just as you go forward, be cognizant of these types of mistakes. Now let's move on to the next concept and talk about functions. So a function can be defined as a unit of code in charge of performing a specific task or routine, and we can recognize a function by its syntax. So it would look something like this. So you can see it's a single word. In this case, it's color-coded with green by Visual Studio Code, and it's next to a set of parentheses. And so inside these parentheses, functions can take a different number of arguments, including no arguments at all, depending on the function. And by arguments, I mean values that act as settings or parameters for the function itself. So for instance, print is a very common function in several programming languages for debugging and troubleshooting parts of the code. It allows us to visualize specific parts of the code, such as a variable, to verify, for instance, that it's running properly. So we could declare a variable, let's say pitch equals 60, and we can use the print function to print this variable inside the terminal. So let's go ahead and type pitch inside the parentheses. Let's save this thing, and we can wait, where are we? Desktop. Where am I? Oh, okay. So I can evaluate this code. Nope. Coding. Okay. And so we can see that the value is being printed in the terminal because of the print function. Now another example of a function could be the round function. And so what round does is it takes a single argument, in this case a number, and rounds it up or down to the nearest integer. So let's say pitch equals 60.5 or 60.3. We can do this. So what it would do is it would take this floating point number 60.3 and round it down to 60 because it's the nearest integer. And we can also declare variables or declare variables containing a function inside it. So we can say rounded pitch equals round pitch, and we can actually use a print function to print this. So we save this and we evaluate the code, and you can see that it keeps printing a 60 because we have rounded the number down. If we were to change this, for example, to 2.8, it would print a number 3 because it's rounding up to the nearest integer, and so that is in fact what's happening. So with that being said, we'll be examining functions on a case-by-case basis as we go through the next tutorials. For now, we can move on and talk about data types. Okay, so the 4 different data types that you will need to know about when writing RTcmix scripts are, and I'm going to type them here in a comment, are float, string, list, and handle. So this 4th one, the handle, I'm not going to talk about this one just because I believe it's easier to understand in practice than in theory. So you don't have to worry about this one for now. What I'm going to do is talk a little bit about these first 3. And just in case it's not very clear, data types are anything that we can manipulate in our code. So for example, that's why you can't see things like functions or variables listed as data types, because in the case of functions, functions are used to manipulate data and variables store data, but you don't actually manipulate the variable identifier, you manipulate the value stored inside of it. And the type of value or data type stored inside a variable, for instance, is precisely what we are interested in. So let's begin with float. So float in RTcmix is essentially any number, whether it's a whole number, a rational number, or a decimal number. So if I type 1 or 1.5 or 1/2, these 3 numbers fall under the same umbrella of float data type, which is actually a pretty unusual thing in most programming environments, but I guess that's just the way it is. Now, a string is anything that we type inside a pair of quotation marks. So something like this would be considered a string, and depending on the context, a string may or may not influence the behavior of our RTcmix script, and we'll see some examples of this in other tutorials. Now let's discuss list. So lists, also known as arrays, are data structures containing any number of elements, including 0 elements, and these elements can belong to any of the 4 data types, including lists. So one way we can recognize a list or an array is by the syntax, because the elements of a list are inside a pair of curly braces. So I could declare a variable called basket, and this variable will be of data type list, because you can see that I'm using curly braces, and in this case this list contains 0 elements, so it's an empty list. We could also type a list with elements, so I'm just gonna call this one salad, And this variable, which is of data type list, also will contain 3 elements. So let's say hello, the first one, the second one, let's say 3.5, and the third one will be a list. So again, as you can see, this list contains 3 elements, each element of a different data type, the first one being a string, the second one being a float, and the third one being a list, which itself contains a float. Now the elements inside of a list can be referenced by their index, and indexes begin from 0 to the number of elements in the list minus 1. So in this case, the list has 3 elements, and they would be indexed from 0 to 2. So 0, 1, and 2. And we could either retrieve or specify elements in a list by using the following syntax. So we can say list name, open brackets, and inside the brackets we specify the index. So if I typed salad, open brackets, and specify the index 1, this would be referencing this float, the 3.5. And we can actually verify this by using the print function and printing this thing in the terminal. So if I execute this code in RTcmix, I should be able to see this 3.5 printed in terminal, and that's indeed what happens. If I were to change this index to 2, what I would be referencing is this list right here. And so we should be able to see this list printed in the terminal. And here it is. So you can actually see that the lists in terminal are printed inside brackets as opposed to curly braces in the way you type them in your text editor. And that's pretty much all you need to know about data types. I think we're ready to move on to the next topic, which is conditionals. So conditionals are pieces of code where their execution depends on whether a statement we give is true or false. And these statements are commonly known as Boolean conditions, and the way they are evaluated is if the statement is true, the computer will output a 1, and if the statement is, on the other hand, false, it will output a 0. So there are 3 main different types of conditionals that we'll be using in RTcmix, and these are, I'm going to type them as a comment. So the first one is if, the second one is else, and the third one is else if. So looking at the first one, the if conditional would look something like this. Let me use again this comment format. So the syntax for if would be something like if open parentheses Boolean condition inside the condition inside the parentheses, and then we open curly braces, and whatever is inside the curly braces would be code to be executed if condition is true, or in other words, if it's 1. So one way we can interpret the syntax is if the statement that we put inside the parentheses is true, then whatever is inside of this thing will be read by the computer, And on the other hand, if the statement is false, then the computer will ignore whatever is inside this thing and jump to the next piece of code. Now, how exactly do we state a Boolean condition? Well, Boolean conditions are often use something called comparison operators. Comparison operators, comparison operators and logical operators. So an example of a comparison operator used within the context of an if conditional would look something like this. So let's say we want to evaluate whether a variable is a positive number or not. So we can declare a variable, let's say x equals 3, and then we can say if x is greater than 0, then we're going to use the print function and print the string positive. So I can save this and I'm going to evaluate this in terminal. Let's see, I can type cmix, left arrow, and then coding 101.seo. And so because x is greater than 0, we should be able to see the positive printed in terminal, and that is indeed what happens. Now let's take a look at the else conditional. So the else conditional is always used in conjunction and after an if conditional, like this. So you can type else, and we also open curly braces, but we don't have to give a Boolean statement. So what this means is that after the Boolean condition of the if statement has been evaluated, if this condition is false, then the computer will skip this code and jump to whatever is inside these curly braces and is going to execute this code. So for example, we could say in this particular example that if this statement is false, then we can print the string negative or 0. And so if it's true that the variable x is greater than 0, it'll print positive, and if it's false, it should jump to the else statement and print this. And so we can change this to, let's say, -3, and we can execute this code, and we should be able to see that it printed negative or 0. But what if we wanted to be a little bit more specific in this example and differentiate whenever we type a negative number from a 0? And this is a good example for using the third kind of conditional, which is the else if. So the else if statement must always be used in between an if and an else statement. So if we were to include an else if statement in this example, it would look something like this: else if, and else if does require another Boolean condition. So we can say else if x is less than 0, we want to execute a different piece of code, and what we do is say print negative. So what this would do is evaluate x. If this statement turns out to be false, it's going to skip to else if. If it turns to be false, then it will jump to this one. If it's true, then it will evaluate this code and jump and ignore whatever is inside the else. So we can get rid of this thing and say that if x is greater than 0, print positive, is if x is less than 0, print negative, and if none of those conditions are true, then just print 0. So so far we've only used comparison operators only, such as the greater than and less than, but we can also use logical operators to combine multiple Boolean conditions that would provide a single true or false evaluation. And the two logical operators that we can use are the logical OR, which is the following syntax, and the logical AND, which is this one. So for instance, if we were typing the following, var 1 equals 10, var 2 equals minus 10, we can use the following conditional. I'm going to get rid of this one. Okay. So if I say if variable 1 is greater than 0, and if variable 2 is less than 0, then I want the computer to execute the code inside, which in this case we can just say, for example, print the word or the string yes. And if none of these conditions are true, then print no. So if we execute this code, because variable 1 is actually greater than 0 and variable 2 is actually less than 0, this should combine to produce a true evaluation, which means that the print with the string yes should be printed, and that is what happens. If we were to change this to both being positive, that means that the second statement or the second Boolean condition here would be false, which means that the entire combination of these two would be false, because the AND logical operator requires both of these to be true in order to output a true evaluation. So if we do this, we can say that it says no. And if we were to use the logical OR, we would be able to get a print yes string, because even though this one is not true, this one is, and that's what OR does. As long as one of these two Boolean conditions is met, then that's all it needs to execute the code inside the curly braces. So if I were to execute this code, we can see that it goes with the print yes. Now, as a last comment before we get into loops, I want to show you other comparison operators that will be available for you to use. So those comparison operators include, so the less than we just used, less than, greater than, less than or equals, less than or equals to, greater than or equals, equals to, And pay attention to this one, because this is a very common mistake. There's also one that looks like this, that is called equals 2. And this is not to be confused with the single equal sign, which is used to declare or to declare a value for a variable. So if you are using a Boolean condition and you do this, what this would mean is you're defining variable 2 as opposed to declaring a Boolean condition to evaluate whether variable var2 equals to 0 or not. And as a last conditional or comparison operator, you can use the exclamation mark equals, which would mean not equals to. And so I think those are pretty much all the comparison operators that you can use in RTcmix. Now let's take a look at what loops are and how they work. So loops are extremely useful for computer programming because they allow the computer to repeatedly perform a task until a given Boolean condition is met. So for every iteration of the loop, the computer checks if the condition is true, and if it is, the computer performs another iteration of the task, but if it isn't, then the computer will then exit the loop. So there are two different ways of implementing loops in RTcmix. So those two ways are, this is not a comment. Those two ways are the while loop and the for loop. So the syntax for the while loop is the simplest of the two and looks something like this. So the syntax would be while open parentheses Boolean condition, then open curly braces, and inside the curly braces the task to be repeated until the Boolean condition is false. So an example of a while loop would be something like this. So let's define a variable named x, and x is equal to 0. Let's say while x is less than 10, we will the computer will execute the piece of code that is inside the curly braces, so we can put some code inside. Let's say that every time the loop runs, every time the loop repeats, we will print x, and before repeating again, we will say that x equals x plus 1. So in this example, the computer would check whether x is in fact less than 10. So it initially is, and since x is equals to 0, this means that the Boolean condition is true, and the code inside the curly braces will be executed. So it will first print the value inside x, which the first time is 0, and then the stored value will be modified by adding 1 to it. This means that the next iteration of in the next iteration, x will no longer be equal to 0 but to 1, and since x would still be less than 10, it will perform another iteration until it reaches 10 and then exits the code. So if we run this piece of code in RTcmix, you should be able to see a a printed series of numbers from 0 to 9. So here it is. And notice that 10 is not included because the condition says that that for this code to be executed, x needs to be less than 10. So if it's equal, that means that the statement, that the Boolean condition would be false, and this code will not be executed again. Now let's move to the for loop. And so for the for loop, things are actually a little bit more specific than the while loop, and it's one that I personally use the most. So the syntax for the for loop, something like this. So for initialization, semicolon, condition, semicolon, iteration, and then we open curly braces, and inside would be the task to be repeated until Boolean condition is false. So for instance, we can type the following for loop. So you can say for x equals 0, semicolon, x less than 10, semicolon, x equals x plus 1, and then we open curly braces, and the task that I want to perform for every iteration of the loop will be using the print function to print x. So I'm going to save this, and what this means is we are initializing the loop with by declaring a variable that will act as a counter. Then we specify a Boolean condition that needs to be true for the loop to continue performing the task inside the loop. And then we have an expression that will modify the initial variable, this one, every time the loop repeats. So if we run the script, we should be able to see the same series of numbers that we just printed, right? Now, one thing that I would recommend is, instead of typing this awkward x equals x plus 1, we can do something a little bit more elegant and use an alternate syntax, which is x plus equals 1, which has exactly the same effect as what we had before. And this same syntax applies for other binary operations such as subtraction, multiplication, or division. However, if you feel like this approach is rather confusing to you, it's also fine, and you can just type this expression how we had it before. Now that we have discussed loops, I think that's a good introduction as any for basic computer programming skills. I hope this was useful and clear enough for you. But again, if you find all this stuff overwhelming or confusing, you don't have to worry about it. It's okay to not get it right away. And you'll notice that as you start implementing them, implementing these concepts in musical context, you'll gain a better understanding of what they do and how to use them. And lastly, don't forget to leave questions or comments if you have any, and thank you so much for watching.